Hello, this is Jesse, and in this tutorial I'm going to be going over creating a phylogenetic tree using MegaX and PhyML and JalView. So we're going to be using instances where we'll take a protein sequence, do a blast search, gather those similar sequences, and create a tree based off of those sequences. And we'll also later use ribosomal RNA sequences from the Ribosomal Database project. There's a database that was annotated ribosomal RNA, and we can use that to create a tree as well. And I also have provided in the Word document some information based off of the methods used and in what cases would you use certain methods. But in this video I'm going to be particularly going over just using the software to create the trees. So first is just Mega. You can go to this link to download Mega. Once you download it, open it up and copy and paste or copy this sequence right here I've given you, and we're going to gather similar sequences using BLAST. So first you can go to click on Align. Once you open up Mega, click on the Align icon and then click Do BLAST Search. And then you can copy and paste the sequence. It's just like a normal BLAST search, but we're just in the Mega web browser, and we can make sure we click over to BLAST P instead of BLAST N. And I'm going to do a quick blast search, non-redundant protein sequence database, and I'm going to go ahead and click blast. Once the results are back, once we get the hits, I can click sequences that I want to use in the tree. So in this case, if I click, just say I want to add this to my tree I want to use, I can click NP accession, click on the accession number here, and I can go to GenPep, and I can go to FASTA, but the text format, and it's going to bring me to the text formatted FASTA, and I click Add to Alignment, and that's one sequence. I've already gone ahead and have completed this part, so the video will be quicker. But here you can see that I have additional 11th sequence that I just added by clicking Add to Alignment. I can do this for every sequence I want to add to my alignment. So I want to add this sequence to my alignment. I do the same thing I just did. Click on the accession number, go to GenPep, click the down arrow, click FASTA text, and then click Add to Alignment. Okay. Now, if you think this is too tedious for you, there's another route. If I'm interested in the first two sequences, and then I want to click some other sequences that have lower identity scores, and then a 50. I'm just clicking sequences. Now, your homework or the test might ask for sequences of particular or sequences that have e-values in a certain range or identity score in a certain range, and that would be your criteria on what sequences you need to choose. Okay, usually you want sequences that are similar or highly similar, and then sequences that aren't so similar, like in the 60 range, and then maybe one or two sequences that are maybe in the 50 range, because in this case we have ranging from 100% to 50, so the lowest possible would be around the 50s, maybe a little bit lower, so we'll go with one with the 50, and then we'll pick some in the 60s, then in the 70s, maybe one in the 80s, and then two or three in the higher percentages that's similar to our protein. And make sure you include the actual protein sequence that you actually did the BLAST alignment with. You're gathering similar sequences to create a tree with the sequence you did the search with. So once you have your sequences selected, you can click on Download and go to Continue, and then you're going to save it. I'm going to save it as .fasta file. So I'm going to click on Save, and now I just save these sequences to my computer. I can X out of Mega web browser. I can click on Align and I can click on File, open a file session, and I can click on the file just saved, which is the sequence dump.fasta. I can open it here, click on Yes, I already have one open. I'm going to save the file I have previously done. I'm going to click on Align. Save this. Okay, so here's the sequences I just saved from the BLAST alignment. So here it is right here. Now, from here, I can align the file. I can align the sequences using alignment, and I can use the muscle algorithm to align sequences, and I can keep defaults and just click OK. And here's the multiple sequence alignment. And then I need to save this as a mega format in mega format. So you click on Data, go to Export Alignment, and click Mega Format. And then from there, you would save it as sequencedump.mega, or you can name it whatever you want. But I just named it as sequencedump.meg. And then it'll be mega format, because in the next step, the next process will need and can only read the file in mega format. You won't be able to create your tree using mega if it's not in the mega format. The alignment is not in mega format. So I can exit out of here. I already have a sequence saved, so after you save your multiple sequence alignment as in mega format, click on phylogeny, and then you can choose one of these methods to create a tree. In this example, I'm going to use the maximum likelihood tree method. And I can click on the alignment that I saved. Okay, and then I can, in this example, I can use the bootstrap method, and then I can click on methods. I think that the highest it goes is to 2,000 replications, but I'm going to just click, I just use 50, so it doesn't take as long. The higher you go, the longer it takes. And the bootstrap method is going to give you the reliability of that particular node in the tree, in which I'll show you a tree once it's completed. And then for the substitution model, I use the WAG model. And the rates and patterns, I use the gamma distributed with invariant sites. And partial deletion for my gaps and missing data treatment. And then you click OK, and it will run the alignment for you. And in this case, once you run it, you should get a tree back. I've already ran the tree. I've already ran the computation, and I get the tree back. And here's the tree, and you can see that we have these values at each node. Okay, these values indicate the reliability of this hypothesis of these two being similar or being homologous or not. And so that's the bootstrap method. Kind of gives you a sense of how reliable this tree is using the bootstrap method, right? So you can also visualize the tree in different formats. Go to View,